One last comment on that is actually kind of neat to think about. The suggestion that one might make is, what would happen if I had a compound like this? Is there any practical advantage in having some compound that looks like this? There are actually biomolecules that look like this. They have a water-soluble end to them, and they have what we call a fat-soluble end to them. They have a polar end to them, and they have a non-polar end to them. So you see examples of this all the time in nature, and in fact we take advantage of this to make this compound that we like to call soap. This is a soap in its most rudimentary form. Why? Because what do we want soaps to do? We want to be able to go out into the garage, I know you probably don't do this anymore, and like work on your car and get your hands dirty. So now your hands are covered in this greasy filth, right? And you want to get it off. So you go in the house, and what's the only thing staring you in the face when you go in the house to get rid of it? Water. So you've got this water draining into the sink, and you put your hands down into the water, and you say, why isn't this greasy stuff coming off of my hands? Well, the answer is because water doesn't like the greasy stuff. It doesn't want to be anywhere near it. It doesn't want to be miscible with it. So you say, I've got an idea. Let's go buy ourselves a source of turpentine or gasoline or something like that. And you see, like your dads used to do this. It's illegal now. They still do it. They go buy themselves some solvent. They go out in the street, and then they pour the solvent, the hydrocarbon, all over their hands, and they rub it like that, and they wash the grease off that way. Why? Because the hydrocarbon, the turpentine, the kerosene, the mineral spirits, the paint thinner, those sorts of things are non-polar, and they will get the grease off your hand. But what about something in between, something that's a little bit more environmentally safe? What about the idea of soap? You've got your hands all dirty, you walk into the house, and you pick up a bar of soap, and you rub it all over your hands. That bar of soap rubs all over your hands, and the part of the soap which is fat-soluble, the part of the soap which is non-polar, starts to interact with the grease. And then you put your hands underneath the sink, and there's the water that comes rushing by from the sink. And it allows you to physically wash away this now soapified mixture of grease that you have. So this is a nice practical way to imagine how you can do your cleaning. It's nowhere near as fun as exciting as walking out into the street and pouring kerosene over your hands and ruining the environment. It's a nice intermediate way to do it by using compounds which have a polar part to them and a non-polar part to them to be able to do two jobs at the same time, working together as a team. In fact, this kind of argument is one that will pop up constantly in biochemistry, constantly when you're looking at metabolic processes. So it's important to understand it.